right, Algebra 2 fans. Today we are looking at the natural log, E. E is called the natural base. E is what's called Euler's number. German mathematician. Euler's number E is 2.71828 ... Okay, folks? All it is a button on the calculator. So here's the graphing calculator. Okay. Clear some stuff out. There's two spots to find the E. There's E right there. I don't know if you can see it or not. Right above the divide sign, there's a lowercase e in blue. So you can do second E. And now, if you just want to hit enter, there's your 2.71828, blah, 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 blah. It's another irrational number like pi. Okay? Or if you wanted to do like, this says evaluate E squared. So we could do, second the divide sign, E, and then hit caret key. Now I can just hit 2. E squared, then hit enter. There it is, 7.389. So down to the nearest thousandth. Now another spot to find the E is, if you look at this button right here on the left-hand side here, there's LOG, the one that we're using. Remember, LOG with no base showing is 10. There it is, 10 to the power of x in blue. I don't know if you can see it or not. And then right here, LN, there's our LN, and there's e to the x. Okay, so we could use that. So I could do second e to the x, and now notice it's automatically waiting for me to type something in. Now I'm going to do square root of 5. So what do I have here? Second square root 5. Break out of there, break out of that, hit enter, and I have 9.356. Okay, and then 4e to the third, that's easy to evaluate. 4 next to the e is time, so I can type it in exactly the way we see it. So all I have to do is 4, second the ln, and I'm going to type in 3. And then I have 80.342. Okay? So, what does all this mean? E is called the natural base, so therefore we have a log. So log base E is actually written out this way. It represents ln. Okay? Remember, log of 7 with no base showing is base 10. That's called the common log. I don't need to put the 10 there. Okay, so log of 7 just means log base 10 of 7. Now, every time I see log of E, log base E, we don't see log base E. We always write ln. Now, some calculators use lowercase letters, ln, and this graphing calculator uses capital letters, capital L, capital N. Okay, so it's just a matter of calculator that you're looking at. Okay, yes, the graphing calculator uses capital L, capital N. This old scientific one uses lowercase letter. Okay, look at that, lowercase log, lowercase ln. Okay, on the phone, I'm using my phone to record, so you'd have to turn the phone sideways and look to see what it does for you. It actually shows log base 10, and then it'll show the ln. I don't know if they're capital letters or lowercase. Okay. Now, ln of E is equal to 1. I can type that into the calculator. Okay. On the graphing calculator, I'm going to see that button right there, ln. There's ln. That's what it looks like, ln. Look at that. Capital letter as a button, but in the calculator itself, it shows lowercase letters. Go figure. So second, I'm going to use that E, close parentheses, hit enter, equals 1. Okay? I'm going to show you why. 2 ways. First of all, remember ln is log base E. And then it's of E equals question mark. Okay? And remember, I'm going to rewrite this. To show you why this equals 1, I'm going to rewrite this in exponential form. So I'm going to say e to the question mark equals E. Well, what does the question mark have to be? It's got to be a 1. That's right. That has to be a 1. Okay? Also, look at this. log of 10. If you go to type that in your calculator, that's right, that equals 1. Because what's the base down here on the common log that we don't see? That's right, it's a 10. And so now when I change this to exponential form, here's your 10, there's your base, to the power of 1. There's the base in black, to the exponent 1 equals 10. Okay? So anytime you see ln, that means log base E. But we don't say log base E, it's too much to say. We just say ln. Okay? All right, now let's look at how to solve one of these problems now. First of all, e to the x equals 5. Very, very, very easy to do. Don't, oh my God, I got another letter. No, 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 you do not have two variables here. E is a number, just like pi, that's the Greek letter pi. That's our 3.14159 ... Well, E is Euler's number. It's the natural base. Everything in mathematics, when we start looking at exponential equations and our word problems dealing with exponential equations and science, they use base E, okay? All right, so when they start talking about in physics or in chemistry, when they start talking about half-lives and stuff like that, they're using base E, okay, to represent their values. Base E is just this number. It's Euler's number. And our calculators can handle base E. It's called ln. So this is saying e to the x equals 5. It's saying 2.71828 blah, 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 blah to the power of x equals 5. All I got to do is solve this. Just like before, we're going to take the log of both sides. But I'm not going to use the word log, we're going to use the word ln. So we're going to take the ln of both sides. And when I take the ln of both sides, where do you think this x goes? It goes in front. That's right. So I'm going to write x ln of E equals ln of 5. Okay? So we literally just take the ln of both sides. Okay? And the reason why I'm using ln, because it's log base E. And there's an E right there. And now I just have to finish my problem. Now here's the nice thing about when we see problems that involve E. And I'm using ln. Right over here, what do we know about ln of E? That's right, ln of E is equal to 1. So this right here, ln of E is equal to 1. So this right here is literally, I'm going to write it over here because I'm running out of room, is x times 1 equals ln of 5. Well, do we really need to say x times 1? You're right. So then x equals, and all I have to do is type this into my handy-dandy calculator and figure out the answer. We're going to round to the nearest thousandth. So ln of 5. Hit enter, and we're done with the problem. 1.609 to the nearest thousandth. Okay? That's it. Let's look at the next one. So I'm not using log anymore. I'm using ln. Log, ln. It's just a different base. That's it. Your calculator can do both bases. So I'm now using ln base. I'm using ln for base E. All right, let's look at the next one. Again, here we go, e to the 3x equals 6. So where does this exponent go? That's right, it goes in front. So 3x ln of e is equal to ln of 6. Okay, we got the hard part done. What does ln of e equal? That's your 1 again. So what I'm going to do is I'm going to take myself a half a step here. I'm just going to circle this and put a big giant 1 over it. So here I am, just looking at 3x equals ln of 6. I'll write it out. Okay, and then what do? That's right, we divide by 3. Problem's done. So I'm running out of room here. So I'll write it over here. X equals ln of 6 divided by 3. I divided both sides by 3. Now all I have to do is just type that into the handy-dandy calculator. Here, I'll use this one. So I have ln of 6. There's my ln. Here's my 6. And all I have to do is hit divide by 3. So this is going to do the ln of 6, and then it's going to do divide by 3. And we're done with the problem. We have 0.597. So 0.597. Problem's done. All right, let's look at the next one. Big ugly mess at the top. Who cares? Nobody cares. We've seen problems like this before. Now I'm going to use ln. So remember, this goes in front, and you got to put parentheses. Okay, what goes inside the parentheses? That's right, it's your 2x plus 3. Okay, we take the ln on both sides. There's no fancy math that we have to do here. It's all done in the calculator. Okay, so now what's ln of e? That's right, ln of e is equal to 1. So this right here crosses out and just put a big fat 1 in its spot. So this is what we're looking at. 2x plus 3 is equal to ln of 7. Now, everything from here on in can get done in the calculator. You don't need to show any work. I want to see this, and then all I want to see is x equals. There you go. Fill in the box. Okay, now what do I mean by that? Algebraically, what do? Right, we have to subtract 3. Remember, ln of 7 is some god-awful decimal in the calculator. So, here we go. So, here's my ln of 7. Close my. What am I going to do with the ln of 7 in that 3? Where I got to get rid of the 3. I got to subtract 3. Well, there it is, minus 3. I don't need to write it all down. There I have that negative answer. And now what? That's right. Now I'd have to do with the 2. I got to divide everything by 2. So now just divide by 2, and there's your answer. So negative 0.527. If you wanted to show work, we could do this. So after you subtracted 3, you can write your x equals negative 1.054, then put dot, 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 and then just divide by 2. If you wanted to do that, but you get right down over here, everything's done in your calculator. Subtract 3, divide by 2. You should be able to do that. Obviously, you can't do it in your head because you don't know what ln of 7 is. Okay, number 5. All right, we've seen problems like this before. All right, but first of all, we don't freak out. What's your first steps? All right, we have to start by getting rid of the 2. We need to get this all by itself. That's right, we got to subtract 2 first. So it's 5 e to the x minus 3 equals 8. How did I get 8? I subtracted 2 from both sides. And now what do? That's right, we have to divide by 5. So e to the x minus 3 equals, well, here's my calculator. I'm going to divide by 8. I'm going to divide by 5 in the calculator. So it's 8 divided by 5. 1.6. Okay, so where'd the 1.6 come from? It's already divided both sides by 5. Okay, if you got to write yourself a little note, do it over here on your side. You divided by 5. Okay, There, we got the hard stuff done. Now what do? That's right, we take the ln of both sides. And where does this x minus 3 go? It goes in front. So I have x minus 3 in parentheses, ln of e equals ln of 1.6. And what do we know about ln of e? That's right, that's equal to 1. This right here is equal to 1. Crosses out, put a big giant 1 there. Where am I going to do this? I'll do it over here. So I have x minus 3 equals ln of 1.6. And what do we do now? That's right, all we got to do is add 3 and we're done. So x equals, pull out your calculator. That's right, ln of 1.6, close parentheses, plus 3, and there's your answer. 3.470. Remember I said to the nearest thousandth. All done. Okay? So we did all of these problems using ln. ln of e is equal to 1. ln of e is equal to 1. Okay? Now let's look at question 6 and 7. Question 6 and 7 are different because there's just no e in it. Okay? But you know what? Me personally, I always use ln because log is too many letters for me to write out. I always use ln. The only time I would use log if I saw a base 10 somewhere. And since these aren't base 10s, I always use ln. Okay? So instead of me hitting the log button on the calculator, I hit the ln button. That's it. So where does the 2x go? In front. So it's 2x ln of 3 equals ln of 5. See how quick and easy it is for me to scribble ln? So now what do I have to do? That's right, we just have to divide by the 2 and divide by the ln of 3, and we're done. So I have x equals, and I just got to type this carefully into my calculator. Okay, but you see how fast it is for me to scribble ln? So for me, it's just like an L with a scribble, as opposed to an log. L scribble is easier for me to do than log. All right, so in a handy-dandy calculator, because it's 2 times the ln of 3 on the bottom here, I have to use parentheses. Okay, so it's ln of 5, close parentheses, divided by, open parentheses, then I'm going to do 2 ln of 3, close. And there's my answer, 0.732. Now, look at what I'm going to do here. I'm only going to do this on the calculator. I'm not going to do this on the paper. I could have done this, remember what I said, I could have used log. So you see where all these ln's are? I'm going to change them to logs. So what I'm going to do is scroll up, hit enter, get that back down here. Now you see where my ln is? I'm going to change that to an log. So there's my log of 5, and then here I'm going to change that to an log. There's log of 3. Okay, isn't that exactly what I had up there, but with ln's? Look at this, now hit enter. The exact same answer. Okay, so I always scribble ln. So I'm going to scribble ln here. So I got 3x ln of 4 equals ln of 9. That's right, we divide by the 3 and the ln of 4. So I have x equals, and then I just have to get that typed into the calculator. So ln of 9 divided by, now you could divide by ln of 4, hit enter, then it's that answer divided by 3. So I have 0.528. Okay, so I did it, I divided by the ln of 4, then whatever that answer was, I divided by 3 because they're both in the bottom, as opposed to using the parentheses. So you guys got to figure that out. You need to become your tech savvy with your calculators. For those of you that have the 84, that with you can actually do alpha y equals, and there's your n over d. Okay, some of you have the calculator X on your phone. I believe you'd have to go to math, and I think you have to scroll to num, and I think you go all the way down to the bottom, and there's the n over d. There it is right there, n over d. And there's your fraction button. So it looks like a fraction. So now I can just do ln of 9 on top, close parentheses, and then on the bottom, 3 ln of 4. Break out of there, hit enter. There's our 0.582. All right, folks. So you just picked up a new base. It's called base E. Okay, it's called Euler's number. Euler's number. Have a good day.